covers a lot of ground. We start with some basic definitions, then we talk about thermal expansion, then we talk about the gas laws, we finish up with modes of heat transfer. Very wide range of topics, but the thing that links them all together is the atomic model. We're going to always think about what are the atoms doing. I'm going to start with a quick illustration of that. I have here a plexiglass cylinder, and in the bottom of it there's a piece of nylon, and on top of that is a whole bunch of little spheres. There's a whole bunch of little plastic spheres. And there's a speaker underneath that makes a vibration. It makes those spheres dance and bounce up and down. This is going to be our simulation of a gas, because inside a gas, the atomic model tells us that I have gas molecules that are just moving around at high speeds until they slam into things. And when the molecules slam into things, that's what makes pressure. When the molecules hit this little piston that's at the top, they push on it, they hit it, and they bounce off. So the piston makes a force on the molecules that causes them to change direction, and so the molecules make a force on the piston, and that force is what gives rise to the concept of pressure. When I turn on the speaker, the molecules are moving. It's just these little pieces of plastic are dancing around, and I put energy into them. How could I model the increase in temperature? How would I change the properties of the system to model an increase in the temperature of those gas molecules? We'll give you some choices. And of course, you know temperature just corresponds to the speed at which the molecules move. So if I want to have a higher temperature, I need to have them moving at a higher speed. And so to make them move at a higher speed, I just have to turn up the speaker a little bit. But before we do that, we're going to ask you this. What will happen to the piston if I turn up the speed? And think about this. The piston, what will happen to the piston? And it's free to move up and down. And so if I increase the speed of the molecules, what will happen to the piston? We'll give you some choices. Well, I think you know what's going to happen. If I make the little pieces of plastic that we're using to represent molecules move faster, what happens is they hit the piston harder, and when they hit the piston harder, they push it up. And so we have an expansion. And so we've shown that if I have this gas and I have the molecules dance faster, there's increased pressure, and that increase in pressure causes the piston to move up. This is a great atomic model for some of the properties that we're going to look at in the chapter. And as we look at a bunch of gas law processes, we want you to think about what are the molecules doing. And if we increase their temperature, they're moving faster, they're hitting the walls of the container harder, and so they have an increase in pressure. That's one of the pieces that we'll look at. And we're going to look at some gas law processes and think about what the molecules are doing in these processes in the next segment.